Have you ever wondered how your computer manages to communicate with various devices? It's a fascinating process, and today we're diving into the world of memory and I/O. Specifically, we're answering the question, is virtual memory used when working with port-mapped I/O? I totally get it. It can be confusing to understand how memory works, especially when you're dealing with different types of I/O devices. You're not alone in this. Many people have similar questions about how their systems operate. Let's set the stage. One user recently asked, if I have a memory-mapped I/O device and I want to write to a register at address 0x16D34, is that address a virtual address? They also wondered about port-mapped I/O devices, like a serial port at address 0x3F8. Are these addresses physical or virtual? Sound familiar? Let's explore this together. To understand this, we need to clarify how memory addressing works in x86 architecture. Memory-mapped I/O uses virtual addresses that the CPU translates to physical addresses. But what about port-mapped I/O? Let's break it down. And stick around. By the end of this video, you'll have a clear understanding of how these addresses work, and I promise you'll feel more confident in your tech knowledge. To understand the use of virtual memory with port-mapped input and output, we first need to clarify the difference between memory-mapped I/O and port-mapped I/O. In memory-mapped I/O, the device registers are accessed using virtual addresses, which the CPU translates to physical addresses. In contrast, port-mapped I/O uses a different addressing scheme. When the user writes to a port-mapped device, such as a serial port, the address used, like 0.3F8, is typically a physical address. This means that the CPU does not translate it to a virtual address. On x86 architecture, the distinction is important. The user should remember that while memory-mapped I/O relies on virtual memory management, port-mapped I/O directly interacts with the hardware using physical addresses. In summary, when the user writes to a register for a port-mapped I/O device, such as the serial port at address 0.3F8, they are using a physical address, not a virtual address. Fun fact, the x86 architecture has been around since the late 1970s. It's amazing how far technology has come, yet some concepts remain the same. Now, let's look at the answers provided by other users. This user explains that in x86 architecture, port-mapped I/O operates in a separate address space that does not use virtual memory. Instead, addresses like 0x3F8 are physical addresses. To access these ports, special instructions like in and out are required, as regular memory access won't work. They also note that modern operating systems typically restrict user space processes from accessing these I/O ports. Additionally, the user highlights that early x86 devices had hardwired port addresses, and later technologies like plug-and-play improved device management. However, port-mapped I/O is now discouraged for new hardware designs due to its limitations. That wraps up that answer. Let's move on to another one. This user explains the difference between memory-mapped I/O and port-mapped I/O. Memory-mapped I/O shares the same address space for both memory and I/O devices, meaning addresses like 0x60D34 are virtual and mapped to physical memory. In contrast, port-mapped I/O, such as the address 0x3F8, uses a separate address space and specific instructions for access, indicating it's not a shared address. Here's a quick takeaway. Always remember that memory-mapped I/O uses virtual addresses, while port-mapped I/O generally uses physical addresses. This distinction can save you a lot of confusion in the future. And there you have it. You now understand the difference between virtual and physical addresses in the context of I/O. If you found this video helpful, please subscribe for more tech insights, and don't hesitate to drop your questions in the comments.